So I mentioned there's a second way of creating a thread, and that's to use the runnable interface. And the advantage of using that is it only requires us to implement a single method. Just wondering, can you guess what the name of that method would be if we're using the runnable interface? Well, very similar to the previous way of creating threads, we need to implement the run method. So instead of implementing the run method of a class that subclasses thread, we can have any class implement the runnable interface, and then all we have to do to is add a run method to that class. Of course, we'll then want to write the code in the run method to execute on a thread that we've created. But we'll get to that in a minute. So first, let's create a new class that's going to implement the runnable interface. So I'm going to go over and do that and call the class myRunnable. And this time we're going to do an implements instead of an extends. So we're going to implements the runnable interface. Runnable. And you see it's complaining because it's saying it must be declared abstract or implement the abstract method run. So we obviously need to do just that. We're going to override or implement that method. So come down here to implement the method, which is going to be run. We're going to use another color. Let's use red for this one. So ANSI underscore red plus, maybe make a bit of space so it's a bit nicer, to easier to read. Hello from myRunnables, implementation of run. So we go back to main now. So to run this code on a new thread, we create an instance of the thread class, not a subclass, but this time we pass an instance of the myRunnable class to the thread constructor, and we then call the thread instance's start method just like we did before. So let's add this code just before the second output here. So we'll do it on line 20. So we type thread. So that should be myRunnable thread. myRunnable thread is equal to new thread, and this time we pass a parameter of the new object, which we create by typing new runnable. So we've now created a new thread based on the myRunnable class that we just created a short while ago. Then from there we can type myRunnable thread dot start. So if we run that, and we get hello for myRunnable's implementation of run, which obviously was in red, which we selected for that class. So just as when creating threads by subclassing the thread class, we can also have an anonymous class implement runnable and pass an instance of it to the thread constructor. So let's change the code that we just wrote on line 20 to do something like that. So I'm going to leave the new runnable in there, and I'll just delete this, so I'll leave that there. So new runnable, and then let's create the anonymous class. So we do that by putting a left brace there, and then we can override. So I can do an override, and notice how it's come up with com.timberchalco.myrunnable, so it knows we're overriding that particular run. Select that, close off the brace, and instead of the super.run, need another bracket there. Then we can leave the myRunnable thread.start there. First of all, if we do that and run that, notice how we still get the same output because we've used super.run, so it's running the run method from the myRunnable class. So we close that down, and instead if we get rid of the super, and we put something like, and we'll do an ANSI red again to be consistent, plus hello from the anonymous classes implementation of run. When we do that, we should see that we get the output from the anonymous class this time because we've overridden the run method. Hello from the anonymous class implementation of run. So a question now you may have is, why should we use runnable versus subclassing the thread class? In other words, when should we use either way? Well, most of the time developers use the runnable way of doing things. The reason is that it's more convenient, and there's also many methods in the Java API that want a runnable instance passed to them. For example, since the introduction of Lambda expressions, it's become even more convenient to use anonymous runnable instances. So when we have a choice, because we're not calling a method that requires one or the other, there isn't really a right or wrong answer, but most developers use a runnable because it's more flexible. So that would be my recommendation, is to consider doing that. But when we read code written by others, You'll probably see that more often than not, that they'll be using a runnable version. So one thing we haven't mentioned is that a thread will terminate when it returns from its run method, either implicitly because it reaches the method's end or explicitly because it executes a return statement. Now, a common mistake when creating and running threads is to call the thread's instance run method instead of the start method. So remember that we have to implement the run method, but we don't call it directly. The JVM will actually call that for us. But what happens if we make this mistake? Well, our application won't crash, but instead of running the code in the run method on a new thread, the code's going to be run on on the same thread that called the run method. That sounds a little bit confusing, but let's show this in action. And another good thing that we can do is we can set the name of a thread by using the setName method. So let's do that for the thread that we created earlier to distinguish it from another, so we know exactly where our code's running. So we'll change the another thread here on line 12, and let's set it to another name. So it's going to be another thread dot set name, and we'll call that something like another thread, just so it's clear. You'll see why shortly. And if we go back to the another thread class, hello from another thread, but instead of putting from another thread, let's change this and put hello from plus, and we'll use it plus current thread dot get name. It's going to return the name of the current thread that's being executed. So if we run the code now back in main, you can see hello from another thread, and because we set the another thread instance to set name to another thread there. So that's doing as we thought it would. It's creating and running the code in that thread. So if we close this down, but if we make the common mistake now of calling the run method directly rather than the start method, we'll see something different pop up. So we'll change now on line 14 dot start to dot run, like so. And now when we run it, you can see we've got an entirely different result there. We've got hello from main. So clearly it's now not running in the same thread, it's running on the main thread, which the main method is actually running on. So that's a very important reason why you don't want to be calling the run method directly and why you want to be calling the start method instead. So let's change that back now to start and run it again, and we should see the blue output is now running, which it is on the other thread. So now that we know how to create and start threads, let's look at what else we can do with threads when they're running. Now we can ask them to sleep or to stop executing for a specific amount of time. Now you might want to do that to give other threads the opportunity to run, and you might also want the thread to do something every time a specific amount of time has passed. For example, we might want to write something to a file every 15 seconds, or we might want to check for data we've requested every 2 seconds. We might also want a thread to sleep when we know that it's got to wait for another thread to do something, and we know that the other thread only does it every 10 seconds, for example. So what we could do is put the first thread to sleep for 10 seconds rather than having it continue to run when we know it's going to be at least 10 seconds before it gets any results from the second thread. So that all sounds a little bit like hocus pocus. Let's go back to the another thread and put some code in practice. So we're going to put some code in the run method for the another thread. So let's add a try block and get it to sleep for 3 seconds. So we're going to type try, and we're going to do thread.sleep. And notice how the input, the argument it's looking for is milliseconds. So 3 seconds will be 3,000 milliseconds. Then we need to catch the exception here, which is interrupted exception, which is the exception we need to catch when we're using a thread.sleep. And I'm going to put out a message there, ANSI blue plus another thread woke me up, because that will be executed if another thread did just that. Then after that we can put in some message here to say ANSI blue again, blue plus 3 seconds have passed and I'm awake. Okay, so you can see what we've done there. We've added a try catch, and we've got the thread, or told the thread to sleep for 3 seconds, and the exception will only be thrown if another thread did wake us up. So if that's the case, we're printing out a message just to indicate that. Now that doesn't happen, we come down here after 3 seconds have elapsed to say that we're now awake. So to see this, let's just have a look at main. We're going to run main and just watch the output when we run this. And notice that it printed the initial message, And that's because we had the initial message going back to our another thread. The first message was printed out immediately, then there was a pause there for 3 seconds, and then it finally come back and said 3 seconds have passed and I'm awake. And just out of interest, if you go just go back and have a look where we added the dot sleep, we looked at this, I think I showed that briefly before. Sleep has got 2 options there. We've got the first method we used was just had a parameter of milliseconds, so we used that for 3000. But the overloaded method also accepts the milliseconds, but also nanoseconds. So in that second scenario, it adds the 2 together to determine what the sleep interval is. If you want to be a bit more precise, in other words. But in our case, we just used the first method and just specified exactly 3 seconds or 3000 milliseconds. So as I alluded to, it's possible for a thread to wake up prematurely because another thread interrupts it, which we'll be talking about in a moment. And of course, when that happens, as I mentioned, the interrupted exception is thrown. Now, if the thread isn't interrupted, as you saw, it woke up after 3 seconds and then printed the line about being awake. And that worked, obviously, because at this stage, none of the other threads we've created has got any code that interrupts this thread. And so, of course, we didn't get the exception thrown. But it's important here to note that it's never guaranteed that the thread will sleep for the interval we specified. It could be interrupted, just as we've discussed. Also, the JVM has to call the underlying operating system to put the thread to sleep, and it's possible that the operating system may not support the granularity that it's asking for. So, for example, it may not support nanoseconds. So it's really operating system dependent, operating system and JVM independent as to how long that will be. So again, as you saw, there was clearly a delay there. If I run it again, see the first message is output and we wait for 3 seconds, and then we'll see the second one come on the screen after the 3 seconds had elapsed. So just before we finish this video, let's talk a bit more about interrupts. So we interrupt a thread when we want it to stop what it's doing and to do something else. Now, more often than not, when you do that, you'll interrupt a thread because we want it to terminate. So as an example, suppose we've got a thread that's monitoring a buffer for data that another thread's fetching. So when the other thread determines that there will never be any more data to fetch for whatever reason, we can interrupt the monitoring thread and then it will terminate. So there's 2 ways for threads to notice that they've been interrupted. The first way is to catch the interrupted exception, and we wrote the code for that in the run method for the another thread class. We saw that will be thrown with the sleep method there. When the run method doesn't call any methods that throw interrupted exception, it should call the interrupted method periodically to check whether it's been interrupted. And that method will return true when another thread has interrupted it. But how does one thread interrupt another? Well, it calls the interrupt method on the thread instance that it wants to interrupt. Now, of course, that means that it'll need a reference to the thread instance to be able to do that, to be able to call the interrupt method on that other thread. So I'm going to end the video here. In the next video, what we're going to do is we're going to modify our code to have one of our other threads interrupt the another thread instance when it's sleeping, just to see how that works. So let's work on that in the next video.